Great to see you here in our next video about the Chinese remainder theorem. My name is Luc de Ceuster. I'm founder of the Ceuster Academy. And before we start with this video, do not forget to click the subscribe button if you didn't subscribe to our channel yet. If you want to be informed whenever we have a new video, do not forget to click the bell button. But let's now have a look at another linear congruence problem. Another problem. Great to see you here again. A new video offered to you by the Ceuster Academy. If you didn't click the subscribe button yet, do it now. Click the bell button so every time we have a new video, YouTube will inform you about it. My name is Luc de Ceuster, founder of the Ceuster Academy, and in this video I will talk to you about the Chinese remainder theorem, and we are going to resolve a new problem. This problem now is composed of three linear congruences. X is congruent to 2 modulus 7, x is congruent with 4 modulus 11, and x is congruent with 9 modulus 13. Basically it means we're looking for a number x, which when we divide it by 7, the remainder is 2. When we divide x by 11, we have a remainder of 4. And when we divide x by 13, the remainder is 9. Let's now go through the different steps like we did before. First of all, step 1. We have to verify if those moduli are relatively prime. So it means that we have to verify if the GCD of Mi Mj is equal to 1 when I is not equal to j. Now in this case it's very easy because the numbers 7, 11 and 13 are special numbers. They're all prime numbers, so they always have a GCD which is equal to 1. So this is confirmed, which means we have one unique solution for this problem. The second step, step 2, we have to find the moduli m which is m1 times m2 times m3, which is in fact 7 times 11 times 13. And when you calculate this, this will be equal to 1001. So the solution we will find, x, will be equivalent modulus 1001. So that's finished. The next step 3 is finding the big Mi, which is m divided by mi. So we find big M1, which is equal to 1001 divided by 7, which gives us the number 143. Then we find M2 is 1001 divided by 11, which is equal to 91. And finally we have M3, which is equal to 1001 divided by 13, which is equal to 77. Based on those equations, based on the elements that we find here, we can write in step 4 the equations to find x1, x2 and x3. So here we can write xi times mi is congruent with 1 modulus mi. When we look at the first equation, we have x1, m1, so we have 143 times x1 is congruent with 1 modulus 7. Now we can rewrite this as 143 modulus 7 is the same as 3 times x1 is congruent with 1 modulus 7. Now we have to find the modular inverse of 3 modulus 7. Now when we look at this, it's very easy to find it because when we multiply both sides with 5, 5 times 3 is 15. 15 modulus 7 is in fact equal to 1. So we find here x1 is 5. The second equation is 91 times x2 is congruent 1 modulus 11. We can rewrite this 11 and 91. We can say that basically this becomes also 91, 11 times 8 is 88. So we have 3. 91 is 8 times 11 plus 3. So we find here 3x2 is congruent with 1 modulus 11. And we see when we multiply both sides with 4, we have 12, and 12 is equal to 11 plus 1, so the modulus is 1, and we can say that x2 is equal to 4. The last one, we have 77. x3 is congruent with 1 modulus 13. Now, what we can do here, 77 is equal to, when we look at it, 5 times 13 plus 12. And we find here, this is 50, this is 65, plus 12 is 77. So we find here 12x3 is equivalent with 1 modulus 13. And we can find that the modular inverse in that case is 12. So we multiply both sides with 12. 12 times 12 is 144, which is modulus 13 equal to 1. So we can say that x3 is equal to 12. So basically what we found here, we have the terms b1, b2, b3. We have m1, m2, m3. And we have x1, x2, and x3. Now we can put all the information in a table and calculate the value of x modulus 1001 and see what the final result is. What is the x value that complies with these 3 linear congruences simultaneously? Now we can put everything in a table. So we have the coefficients bi, 2, 4, and 9. We have the coefficients xi we found in the previous calculation being 5, 4, and 12. And the mi, big Mi, 143, 91, and 77. So when we multiply those, we find 1430. The second one, 4 times 4 times 91, is 1456. And the last one, 9 times 12 times 77, is in fact 8316. When we put all of them together, we find 11,202 modulus 1001. So we can complete this now. We can say that x is equal to 11,202 modulus 1001, which is in fact equal to 191. So the number that we are looking for that complies with those 3 linear congruences simultaneously is 191. This was the end of the second exercise. We will do some more exercises related to the Chinese remainder theorem. Anyway, don't forget to read the text below the video. You find links to our different courses, and with every course you have a very interesting coupon that will give you a great discount when you would buy the course. When you didn't subscribe to our YouTube channel yet, this is the moment to subscribe, click the bell button, and every time we post a new video, YouTube will inform you. I'm looking forward to seeing you next time. Thank you and bye-bye.